Hello, hi everybody. I am Ram Mohan. I am working as head of electronics department at Government Polytechnic, Mahabubnagar. The subject I am handling is basic electrical and electronics engineering for the diploma first years. The topic we are dealing here is the inductors and transformers. The subtopic for the discussion of this session is the working principle of the transformers. So, let us see the objective of this session. The objective. On the completion of this session, you would be able to know the working principle of the transformer. So, we'll understand the working of a transformer. Let us recap what we have learned till now. So, we have understood what is self inductance. Then we have also learned and discussed about mutual inductance. And now let us see the principle of a transformer. The transformer works on the principle of mutual induction of two coils. When the current in the primary coil is changed, the flux linked to the secondary coil also changes. Consequently, an EMF is induced in the secondary coil. And this is the basic principle of transformer. Now, in its most basic form, a transformer consists of a primary coil or winding, then a secondary coil or winding, and also it will have a core that supports the coils on the windings. And let us see the constructional details of the transformers. The transformer will have a laminated steel core, as you can see in the figure. Then you have a primary winding and you also have a secondary winding. So this type of core is called as CI or U and I. So they are linked up like that. So we have to close the magnetic circuit of the transformer of the two coils. Only then there will be interaction between the two. Now it mainly consists of two inductive coils which are electrically separated but magnetically coupled, and this coupling is one coil of the transformer is connected to an AC supply. Because we are talking of a transformer, so we use it either for step up or step down, or we'll see what actually it is meant for. So one coil of the transformer is connected to an AC supply. An AC produces an alternating flux in the laminated core. So it produces an AC flux in the laminated core. Do you know what happens when the primary winding of a transformer is connected to a DC supply? There is no changing flux. It should not work. Let us see what happens. Discuss and see what it is going to happen. The flux produced will not vary but remains constant in the magnitude, and therefore no EMF will be induced in the secondary. But the core will get saturated because of the constant DC voltage applied to that. So the flux produced will not vary but remains constant, and the magnitude, and therefore no EMF will be induced in the secondary coil of the winding of the transformer. So let us see further. Now let us see the working principle of transformer. So most of this flux links with the other coil through the magnetic circuit. So according to Faraday's laws, an EMF is produced in the other coil. So the coil connected to the supply mains is called the primary winding. The coil connected to the load circuit is called as the secondary winding. The EMF induced in a transformer Yes, so here we can see the principle of working of the transformer. The blue side coil is the primary winding and the yellow color is here indicated as the secondary winding. So the primary side when the current is flowing, you can see that a arrow is shown in the ferrite. Here actually there is a core. Let us not discuss about type of the core. So because of the changing current in the coil, you can see that the current direction is changing alternately, because here we are discussing about AC being applied to a primary conductor. So the flux that is being generated by the applied voltage will change in the direction every 180 degrees of turns or phase shift. So here you can see also the flux direction is changing. So due to the primary voltage applied, like let us assume the mains on the primary, there is flux linkage, and that results in a flux that is changing alternatively, changing the phase or the direction. So because of that, the flux linkage's direction that is traveling onto the magnetic circuit being linked to the secondary, that results in an EMF being induced in the coil of the secondary winding. So here you can see that this flux is linking the secondary coil, and the secondary coil is giving out some EMF induced there. So we have an equation for that, but as far as the principle is concerned, this, as you can see, a flux that is being generated by the primary coil, the flux that is changing will also induce an EMF in the secondary of the coil. So that EMF you will take it as the secondary output voltage. So this is the basic principle for the working of the coil, I mean the transformer, sorry. Yes. So in this figure also, in the animation, you can see that the left side is primary and the right side is secondary. You can assume vice versa also, it works. And you have a common magnetic circuit. So electrically these two windings are different, but there is a connection or linkage between these two, and that link is because of the magnetic flux. So they are having a common magnetic circuit. And here you can see on the windings, inside the winding the current direction is changing slowly, and so also the flux that is generated because of the current flow direction is also changing in all the coils or the windings of that primary wire. So this is actually going to change the flux direction in the magnetic circuit. So a changing flux is going to induce or an EMF in the other winding, that is secondary for our discussion. So here we have another notation wherein you can see that the changing flux will induce EMF and there will be a magnetic circuit. So here on the left side you can see there is a winding, and the red and blue combination is a bar magnet, and the magnetic field is changing because it is moving between left and right to control within the coil. So this changing of the magnetic field, so this magnetic field, it is changing the magnetic flux in the left side circuit, and that is actually generating an EMF. So that due to that there is a current flowing within the transformer's primary on the left side of the coil. So when the current is flowing there, which is of changing current, changing phase rather, there is a magnetic field, and because the other coil is in the magnetic field of that primary, so there will be EMF that will be induced in the secondary. So also there will be induced EMF in the secondary. So this is another notation for us to understand the concept of transformer. So here also you see there is entering the current, and that is the magnetic flux going through the magnetic circuit, and that is when it is reaching the secondary coil, there is current coming out. Well, for logically it is shown there that the entry of is on the top of the coil on the left side, and then the exit point for the induced EMF is on the bottom side. Because we'll understand this concept, the induced EMF will be 180 degrees out of phase of the input. So this is another rotation to see how it works, that is the working of a transformer. Now let us look at the value of the EMF that is induced in a transformer. So the induced EMF is given by an expression E equal to minus n d phi by dt. Just now we have discussed and I have told you that the direction of the induced EMF will be 180 degrees out of phase, and here it is indicated by a minus symbol. So the voltage E that is induced is equal to N is the number of turns, is the induced EMF in the volts, and N is the number of turns of the coil, and d phi by dt is the rate of change of flux in the Webers per second square. Sorry, in second. The minus indicates that the induced EMF opposes the effect causing it. So it is opposite. It is exactly opposite. That is 180 degrees out of phase. Now let us see the symbol of a transformer. So this is how the symbol is shown. So normally we talk about step down transformers, and hence the number of turns given on the left side or shown here is more, and the number of turns on the secondary is less. So we have now let us conclude here as far as or we'll just hold. I'll show you one more small bit. So here we can see the notation of a transformer to understand it as a principle. So transformer input is electrical, the output is also we get as electrical again. So input is electrical, output is also electrical. So AC and AC to understand. This is simple notation of a block. So AC here you are looking. This is here we are talking about a step down transformer, as I told you. Normally we mostly discuss about only step down transformers. So here it is. So you have a changing voltage and you have a changing input and output. Can voltage and similarly current. So because the voltage is less, the output current is more. It has to be more because the power has to be same. So P in should be equal to P out. So that is how the relation is standing between these two.
Then the number of turn in second.
So when the primary is having small number, less number of turns, then this is a step down transformer, as you can see in the figure. So voltage applied at the input is large and V output is very less. But actually what happens, the power has to be maintained equally in both the circuits. So I out is high and vice versa. Now you are seeing a reverse one. So this is the magnetic circuit or the core, which is actually linking the primary and the secondary of the circuits. And normally, as I have told you, the laminations that are used are U and I. UI they are called. So this type of laminations are used to reduce the eddy current losses within the core of the coil. Now let us conclude this session and see what we have actually discussed in the session. So we have discussed about the basic working principle of a transformer. Let us just check our quiz, our memory, if we could remember what we have or how best we have actually remembered our discussion topic. So the transformer operates on a steady DC and AC, AC and DC, then none of the above. What's the right answer? It is only AC. So it has to work only on AC. That's the right answer for us. You can see that the color is changing to blue. So it is only AC because for it to work, the logic is changing flux, and for the flux to change, it has to be AC. Next, now a transformer is not used in the DC because why? Because why is it not used in DC? Because there is no need to boost up the DC voltage. Choice A. Because choice B is losses in the DC circuits are high. Choice C, Faraday's law is not valid as the rate of change of flux is 0. Then choice D, harmonics developed in the transformer will cause distortion in the line voltage. What is the right answer? It has to be choice C. Why? Because Faraday's law is not valid as the rate of change of flux is 0 in DC. So you can see that it is getting highlighted, that is choice C with blue color here. One more quiz. Working of the transformer essentially depends upon dash. Choice A is self-inductance. Choice B is mutual inductance. Choice C is magnetic circuit. Choice D is magnetic flux. So the working of the transformer depends upon the mutual inductance. So here the highlighted is choice B, that is mutual inductance, because there has to be mutual inductance and there should be some link between the primary and the secondary, because of which it functions, the working will take place. Now let us see next choice quiz. An open primary in a transformer results in excess current in the secondary, excess induced voltage in the secondary, no induced voltage in the secondary, and no current in the secondary. What's the right answer? That means there is nothing connected to the primary. Will it work? It should not, and it will not. Why? Because no induced voltage in the secondary. There is no output. Right? So the choice C is the right answer over here. Now let us see some frequently asked questions that would come because of these discussions. So explain the working principle of the transformers with neat diagram. So here we will conclude this session with the last choice question, that is here. So we should explain the working principle of transformer with neat diagram. So we can explain the transformer working with the core, primary winding and secondary winding. Hope that is easy and have understood. Thank you very much for being here. Thanks a lot. Thanks.